the shortest path?
Shortest path, that is after we understand what is the graph. It's one of the problems we need to solve.
You can represent a circular path.
Well,
That's the one of the application that we are going to use it based on this characteristic. Graph can, for example, why do you use the serpent? What is the mostly used application of your serpent?
God.
Facebook, Tumblr, Twitter. So actually it is true. So such a social media site makes the boom of the popularity of such a cell phone. So we have used the for the phone or the for text message before, but nobody want to use that right now. So because the social media site. So social media site, what is the most important part of the social media? In other words, if you were Jukebox, where you are going to focus on? Very nice, the fancy, the interface. Connection, which means the more user you have, the more higher popularity of your website, the social network. If you do not have a lot of connection, nobody will use. So Facebook, all the social media site, they focus on how to build up the connection. More and more connection, more and more user. Okay? Then, because of that, the Jukebox will use what? Like. One is a friendship, next one is like. That is true, the likes. It looks like very simple, but it is totally new. The functionality to make I'm interested in you. Even though we do not have the friendship, so I can give my intention. If you are not interested, you will click the like, right? So, but nowadays like has a different, like sad or different feeling, but it was just like somebody published a paper. How many different types of like in the Facebook? They said there's 8 to 10 different types, but anyway, so it's a connection. Then, how can the Jukebox, Facebook, manage such a connection? At that time, not only the Facebook, all of the social media sites use the graph data structure. So nowadays, graph. The reason is that graph can represent such a relationship of the data very easily. Right? Think about the social media site, like the Facebook. So we have user, they like. Okay? How much they like each other? Very strong. You can give the strong edge. Okay? Some of the edges are the attribute edges. You can give the weight. Sometimes connected, sometimes not, and sometimes connected, and connected, and connected, and connected. At this time, we can see even though this node is the most popular one. This Facebook user is the powerful user because it's mostly connected. So we can see easily such a relationship of the data in terms of for the social media site. We can see the relationship of the user very easily using graph because graph can represent such a relationship of data very easily. However, think about the relational model. If you already took the database course, so how can you represent this one, user? And the like table. Then can you find the relationship? So you can do that if you can analyze and do something, but very complicated. But graph can easily show that, the relationship. Then, in a graph, for example, shortest path. So we'd like to know how much close to each other. What is the shortest path to connect another user or another node? Or what did you mention? Circular. For example, whether there exists a circular or not. So these are the common problems to solve in a graph. Good news, it can represent such a characteristic of the relationship, like which one is close, which one is not, and which one is a circle. Problem, it's not easy. to compute. So this is called the graph, usually called the NP-hard problem. Anyone who heard about the NP-hard problem? Yes. What is that?
It's a problem that gets exponentially more difficult to compute.
Then what is the N? What is the P?
Um,
It's the correct answer. It's to solve that problem, it's exponentially hard, the problem. Then, in other words, opposite way. What is the good, the problem, easy problem?
Anything less like quadratic or linear.
Which means if you can optimize the problem. So what is the very popular optimization problem in statistics? Anyone who are taking the data mining class? There are some. Linear regression problem. So regression is one of the optimization, very popular and the long-term history to find the relationship. Sometimes you can represent such a relationship through the linear line. So non-polynomial, this is called a non-polynomial hard. If you can represent a certain problem as a polynomial, that means it's a very easy problem. Not very easy problem, it's in terms of complexity. So it's an easy problem. If you cannot represent such a problem solution as a polynomial, which means exponential and it's not optimized, it's a very hard. So in other words, you need to use the brute force way, each and every case. For example, in the graph, intuitively you can find easily this is a circle, this is a circle. But if you make the program, how can you find? How can you code to identify this one? From your eye, there exists a circle. Using computer should be faster, but no optimized way, no shortcut, shortcut to find this one. Only solution is brute force way, which means starting from one node, check the another node, and is there any? No. So starting this one, check the next and next until you find so you need to check each and every case. So this is in terms of complexity, it will be n squared. Okay, even though look more than n squared, n factorial, something like that. So it is a NP-hard problem. So graph is good for the structure, to represent the relationship of data, but the operations are very difficult to implement and very expensive. However, there are solutions, some solutions to reduce the complexity by the limiting or by assuming something. There are a lot of the such. Still, nowadays, because of the popularity of the social media data, most of all of the social media websites, they use the graph structure. Because of that, eventually, if you are interested in the database, we will have the NoSQL database, like the graph database. We keep the data as a graph. Sometimes we keep the data as a document, not the relational model. So this is the NoSQL database, not only SQL, the other types of the database. Then go back to here. So our goal is that if we represent the process and resource state as a resource allocation graph, our goal is to find the circle. Okay. Then one more thing. Do you think so for example, suppose that you find the circle. Is this the deadlock or not? Always. Deadlock or not? In this case, it's always the deadlock. However, if we assume there are multiple resources, instance, so one of them is allocated to the process 1. Is there any circle inside? Yes, sir. There is a circle. Waiting. This is a circular way. And hold and wait. But is it deadlock or not? What if? This one is a P1. So when P0 requests the resource, this one can be allocated. So it will be completed. All the process requests will be completed. Even though there exists a circle, but in case of the multiple instances, sometimes it's not the deadlock situation. So this is a command decision. If you find the circle, this maybe deadlock. Not always, maybe deadlock. However, if not circle, this is not deadlock. However, to differentiate whether this is really deadlock or not is really expensive. It's a really hard problem. So, but still finding circle is not easy, but in case you find the circle, we consider because this will be deadlock. But not always. It may be deadlock in the inside, but we just consider this is a deadlock. Okay? So don't be confused. It's not really always a deadlock, but we regard the maybe deadlock, we regard that this is a deadlock. Okay? Then let me show the one simple example of the deadlock. So we are going to use this one. So I don't have this. It's very simple, the notation for the resource allocation graph. Sometimes it's called RAG, but there are a lot of such abbreviations. So even in my dissertation, I use the RAG, but that's not the resource allocation graph. It's a region adjacency graph, something like that. So graph user. Okay, so don't have to worry about the right-hand side first. Just to take a look at the RAG. So how many processes? How many? The circle is a processes. So this is 3 processes. How many different types of resources? So 1, 2, 3, 4. Then for example, R1 has how many instances? 1. R3, 1. What about the R2? 2. And what about the R4? So 3 of them. So this is a current at a certain time, the snapshot of the resource and the process, the status. At this time, let us understand what's the meaning of that. Process 1 is holding 1 of R2. Then request the R1, okay, which is held by P2. P2 currently uses R2 and request R3. And also P2 is also hold the R2. Then R3 is held by P3. First question, is there any circle here or not? This is a circle. No, it's not circle because it's going to this one and then there's no the way. Okay? So P3 will be eventually terminated. Okay? It's not requesting any other, eventually terminated. Once P3 is terminated, release the I3, and once I3 is released, the P2 will be completed. Once P2 is completed, P1 is done, so there might be no problem. So this is not the deadlock situation. In other words, this is called safe state, opposite of the deadlock. Okay, what about this? So it's exactly the same, but the P3 is requesting this. The I2. Is it deadlock or not? You can find circle and also another circle. This is a circular way. So this is the deadlock. So no, it's a Holden way. No solution. We will see the solution later. Okay. What about this one? So we have the 4 processes and 2 types of resource. Each resource type has 2 instances. Like the P1 is holding one of R1 and requesting R2 and requesting R1. And P2 is holding this one. So first, is there any circle here? Yes, we can find the circular way here. However, is this the deadlock? No, because P2 will be eventually terminated, completed, then it will be the release. Then once it's released, P1 can use, and P1 will be terminated. Once P1 is terminated, and then also P3 can complete it, and then P4 eventually. So not always the circular way is the deadlock, but maybe deadlock. So overall, because to classify this is a deadlock, this is not deadlock, it will be very, very expensive, as we have seen here. So it's a graph operation. Any graph operation is very, very expensive. Mostly it's a NP-hard problem. It's a brute force way. So instead of considering this is deadlock, this is not just in case of the circle, we consider deadlock. But this is the opposite example of the counter example of the such a case. Okay, so this is a basic the decision. In case of the no circle, no deadlock, but circle maybe deadlock. Okay, then we need to do something. Okay. I'm going to skip this part, but we will see later. So there are 4 requirements of the deadlock, so that we already discussed. So solution from now on. So there are different types of solution. The one is deadlock prevention. Another one is deadlock avoidance. I think so today we can cover up to this much. So first, the deadlock prevention. When I learned the deadlock, it was really confused. What is a prevention? What is a avoidance? It looks like they're very similar, right? Prevent means what? Somebody rule. You prevent from something. You cannot do that. Can you do that? In case you do, it's a violation, right? Prevent, you cannot. Okay? Avoid means, so it's a little bit more relaxed. Okay? There might be possibility, but we avoid such a situation. Or try to avoid the traffic. Try to avoid something. So prevention is really, how can I say? It's the hard decision. Okay, never happen. So for example, how can we prevent the deadlock? It's never ever happen the deadlock. How? We can allow one of these the requirement. For example, first one, no mutual exclusion means you can share the data, share the resource anytime. Is there any deadlock? If you allow the shareable the resource only, no deadlock. Okay? Or hold and wait. You do not allow hold and wait in your operating system, which means how can you terminate the process? You need to serialize. I need this resource, this resource, this resource. So once all of them are available, then the process all the instruction. Okay? Until you get all the available resource, then you need to wait. Then once all of them are available, then terminate. Then there's no wait, just hold, then terminate. So then no hold and wait. Or non-preemptive means you can preemptive. You can allow resume anytime. In case of something, wait and start again later. So that is one possibility. And no circular way. Okay? You cannot request that is held by other. If he is holding this cell phone, I will not. Nobody can request the research. There might be no circular way. So prevention means it's simple. You can allow, relax one of these requirements. Break the requirement. Then no deadlock situation. That makes sense, right? Looks like easy, but practically it's not possible. How can you make the shareable resource For example, the printer. Printer you cannot share. Okay, it should be always the mutual exclusion. How many printer job can you process? Only one printer job, right? So even that cannot be resumed non-preemptive. Not all the cases it is possible. It looks like the simple solution to prevent, but in real life, real situation, is practically not acceptable. So prevention means you prevent. Never ever cause the deadlock. It's a free, deadlock free. But to do that, you need to allow the one of this, break the one of this the rule, but which is not practically possible. So there's a second solution. It's a deadlock avoidance. Deadlock avoidance means in the current state, so it's not deadlock situation. So using the resource allocation graph, there's no the circular weight or no circle. But if somebody requests, like in the previous example, this one, this is a non-deadlock situation. This is okay. But in case P3 requests R2, okay, like this one, that caused the deadlock. Before assign, before accept the request, operating system check whether this request caused the deadlock or not. Okay? For what? To avoid the deadlock. It's not enter, it's not move to the this. Okay? Before move to the this, check whether this, the request caused the deadlock or not. How? The problem is how to check. Okay? How to check? At that time, we are going to use the banker's algorithm. Actually, I was a banker before I moved to United States. Because anyway, even though IT department, I worked for the bank, and actually I was very good during the training. Because during the training, it's a 1 month training for all the policy and the rule of the bank. Because it is true. Actually, the financial related policy, the IT developer is one who knows everything. Because to code, you need to know how to calculate the mortgage rate and so on, really. But the teller who works in the branch, who are in the branch, they do not know much about that. What they know is just a click, click, click. Really. They even do not know how to calculate the interest rate and so on. But you should know to code. So I learned such a thing. But the banker's algorithm means, do you think what is a basic mechanism of a bank? You deposit the money, then withdraw. Then how does the bank make the profit? Just keep. But usually, if you deposit, you get even bank give the money, additional money, right? Even though right now the rate is very low, so like the saving account is 0.01 or 0.1, yes.
The bank invests the money?
Bank can use the money. For example, loan. So if he deposits the money like $1 million, so bank does not keep the $1 million in the safe. Instead, first, the bank can lend the money to others, then 10%. The loan rate, okay? Then from 100,000 I can get a year. Then using that money, I can give the interest rate like 1%. The 9% is the benefit. Okay, then. So that's the only one. So, but if you have the multiple, many customers. So like the total amount is the 1 billion, the deposit. So bank does not keep all the 1 million. It may be possible the all customer request to withdraw the money same time, which is called bank run. Okay, it will be it's a really disaster for the bank. Okay, like the financial crisis, so bank run will be happen at the time. Sometimes they even prevent, even though it's my money, you cannot withdraw the money to save. So instead, bank keep the minimum amount of money. Okay, like the 5% or 7%, only the minimum for the withdrawal or the partial of the money. However, bank should be able to give the money to the customer. Okay, at least by considering. So if he requests the money to the withdrawal, so I can give the money back to him by collecting the loan amount. This one and this one, eventually you should be even, right? If the old customer requests at one time, I cannot, but eventually, one by one, the bank should be able to give the money. That is the banker's algorithm. Similarly, if we consider resource and process requests the resource. But think about the 3 processes, and the 3 processes request the 10 CPU, for example. But I have only the 3 CPU, which means give up? No, instead I can provide the resource one by one. Eventually there might be no problem. So that means if we can find the sequence of the process P3 and the Pn that can be terminated eventually. Okay, this is called the safe state with the banker's algorithm. Otherwise, if we cannot find this one, sometimes it's stuck, which means it is non-safe state. It's a safe state. Non-safe state is a deadlock. However, it's not always a deadlock. Maybe deadlock, but we consider this is a deadlock. Okay? So, problem. So intuitively we can understand. So banker's algorithm will be the input and output will be even. So we can handle such a thing. In case of a process and resource, how can we do that? So to do that, we are going to define several the variable data structure. Before that, let's take a look at the quick example in case of single instance resource. So we have the 3 resources, okay? 3 resources, and let's say we have the 12 magnetic tape resource. 3 process P0, P1, P2. And then we have the 12 the magnetic tape. Magnetic tape is still used. Have you ever used the magnetic tape? Or to listen to the music? Have you ever used the cassette tape?
Yes.
If you are saying yes, you are probably old. Like the Walkman, the 30 years ago. Have you ever heard about the Walkman?
Yeah.
No? It's a Sony product. It is like the iPhone. It's more popular than at the time than iPhone. Everybody keep the Walkman cassette tape, the player, to listen to music. It was kind of the parent of the iPhone, iPod. Okay. Then it used the magnetic tape. This tape style is a magnet. Then we can put something information like the signal, the waveform. Then we can replay the music. Actually, that can be used to store the digital data. For the digital media, so any types of the digital media is based on what? Close or hole. So, for example, the desk, it has a lot of hole. So even I can use this one to represent the images or any kind of data, because the digital data is based on the 0 or 1. If you can represent it, like the CD. CD has track, and if you actually magnify the CD, there's a track, and this one has the hole or the close, hole one close, to represent the digital data, binary data. What about the DVD? DVD is the same, more dense. And what about the rewrite over the CD or rewrite over DVD? You can actually close and open again. That is a rewrite over. That was used in the magnetic tape a long time before. So when I used the computer first time, I stored my program into magnetic tape directly. So if you play the magnetic tape, it's a weird noise sound coming out. Have you ever used the PC communication, the internet through the telephone line? Probably not. So when you connect the internet through the telephone line, it looks like there's something weird sound, noise sound coming out because it's send the binary data. Okay, but that can be changed into analog the sound, so it's noise. It looks like a noise. So magnetic tape is still used the backup device. So because it's a cheap and reliable still. Don't believe your hard disk drive. It's not permanent. So you already encounter such a problem. Your old digital, the image, photo is collapsed because the media is not persistent really. Then you believe. Okay, so we have 12 magnetic tape. Then P0 need 10 of them maximum, and the P1 need 4 of them, and the P2 is 9 of them. And currently it used 5, 2, 2. Then how many available right now? This one is used, so total how many used? 9 of them are used, which means 3 of them are available. Okay, then the P1 need how many more? 2 more. P0 need how many more? 5. P2 need how many more? 7. Then we can complete P1 first because P1 needs 2 more, right? So we have 3 available, then it needs 2 more. So it will be terminated. Then how many more available? We have the 4 more available from the P1. So it's total 7 available. In case of 7 available, we can complete this one, you can complete this one. Oh, no, not that way. Because it's a max need, so currently 2, this will be 5. Then the 5, this one is done, the next P0 is done. Once P0 is done, 5 of them will be returned, the total 10 available. In case of 10 available, this one will be done. So in this order, P1, P0, P2, we can complete all the processes. So this is the safe. Where's the safe? The safe. I think of some area. Safe. Which means no deadlock situation. So this is the banker's algorithm. Very simple banker's algorithm. Even though currently only 3 available, the bank has only the $3 million, $3, but if they request 5 more, 2 more, 7 more, but because each user has even the loan amount, so we can collect. So this is the banker's algorithm. In case single instance, it's very simple to understand. What if the P2 requests 1 more, P2 request, which means 1 of available. So it will be 2, then this one allocated to the